So just another look at an equation. This is the last one. Notice this one's different because we have a sine and a cosine in the same equation. We haven't really seen that before. So we're going to have to talk strategy on that one. Notice I graphed the left side and the right side of the equation, so I'm looking for points of intersection. So I'll move that over so we can see the graph a little more. And it looks like we only really have two solutions, pi over 12 and 5 pi over 12. Because since our interval is usually 0 to 2 pi, this next solution is more than 2 pi, which means not on the interval. So our equation should only have two solutions and denominators of 12. That's interesting. That must mean that we have like a double angle somewhere maybe. Let's figure out how that happens. So now that we know the answers, let's try to arrive at them analytically. So the first thing I notice is there's a common factor of 2 on the left-hand side. So I'm actually going to divide both sides by 2 first, just to make life a little easier on the left-hand side. So there we have that. Now, one strategy, and there are some other strategies that we could use here. There actually is a nice identity that would make this work. But we're not going to go that way right now. We're going to square both sides. And the reason is that when we square both sides, sine x and cosine x, you're going to end up with a sine squared and a cosine squared. And we know that nice things happen when you have sine squared plus cosine squared. So we're going to square both sides. And after doing so, we have sine squared x plus 2 sine x cosine x plus cosine squared x equals, now on the right-hand side, square root of 6 squared is 6, 2 squared is 4, so I'm just going to write that as 3/2. Okay? Well, more fun. Sine squared plus cosine squared, that's 1. So that's going to get replaced. Now, one more thing I'm noticing, maybe I should move the 1 to the other side with the 3/2. It just looks like it belongs over there. Now we're in a bit of a pickle, it looks like, because can't really do much with that unless the right-hand side is 0. I would know exactly what to do. But now remember, 2 sine x cosine x, that should look familiar. That's your double angle identity. So here, it's actually going to be easier to rewrite this back as sine of 2x. Because now we have sine of an angle equals a number. Perfectly done. So, now that we're here, remember that the 2x means 2 revolutions. So if you don't want to have to make the u substitution every time, that probably would be better for you. So if sine is equal to 1/2, the magic angle should be 30 degrees, right? So 30 degrees quadrant 1, 30 degrees quadrant 2. And it looks like our angles are, well, so 2x is equal to, so 2x is the angle, so the 2x is equal to 30 degrees and 150 degrees. Now, as well, we have a second revolution to deal with. So adding 360 to each of these, we get 390 and 510, which means that x is equal to, now divide each one by 2. We have 1575, 195, 255. Okay. So now going back to radian mode. 15 is pi over 12. 75 is 5 pi over 12. 195 is 13 pi over 12. And 255 is 17 pi over 12. Now you're probably thinking to yourself, wait a minute, only pi over 12 and 5 pi over 12 were the solutions on the graph. So where those other two come from? Well, remember that when you square both sides, and I'm just going to write down an equation 5 equals 5. If I square both sides, I still get a true statement, right? But what if I start with the equation -4 equals 4, and I square both sides? Oh, we could be hoodwinked here, because we still get 16 equals 16, so we're led to believe that anything we get from that is a solution. So what's the moral of the story? We have to go back and check our answers. Now, I'm not going to plug them in. You can do this on your own. But the thing you'll notice is that 13 pi over 12 will not be a solution, and neither will 17 pi over 12. When you plug them in, you get the negative square root of 6 on one side and the square root of 6 on the other. So it turns out that these are your only two solutions. So I do encourage you, substitute those two other solutions, supposed solutions, posers I guess we'll call them, into the original equation, and you'll see it doesn't work. So the graph will never lead you astray. If you solve it graphically first, you'll know what kind of solutions you're supposed to get. Then it's a matter of making the analytic part match up. And of course, this is just more fun anyway. It's like solving a puzzle. So I thank you so much for watching, and watch out for more videos.